Good morning, students. Welcome to this second session of the reactions of amines. Yesterday we have seen four reactions of amines that will be converted into different functional groups, or the reactions addressed the classification of amines. Today we will see three reactions that can be shown by amines. So reactions of amines that involves carbylamine reaction, or it is also called as carbylamine test. Then the reaction with aryl sulfonyl chloride. This reaction is also useful for distinguishing the amines. Then at the last we will see the reactions involving diazonium salt. So how we prepare different substituted amines from diazonium salt. As yesterday I have already told you about this diazonium salt. So this diazonium salt can be used in preparation of many other substituted benzene like chlorobenzene, bromo, cyano group, phenol, then benzene itself, nitro group. You can introduce almost 6 or 7 functional groups on the benzene ring with the help of this diazonium salt. Now let us see one by one this carbylamine reaction. First of all we will see. So this reaction is in which the aliphatic or aromatic amines in presence of chloroform, this is chloroform, that is CHCl3, in presence of KOH, that is basic medium, on heating gives isocyanide or carbylamine. This is called as carbylamine. So cyanide and isocyanide, there are two functional groups you may heard about. So this is the cyanide RCN. This is cyanide functional group, or it is called as alkyl cyanide. And this is isocyanide NC. This is isocyanide. So we are preparing this isocyanide from particularly primary amines. So the reaction can only be shown by the primary amines. So let us see the classification. So this primary amines gives you isocyanide, but secondary and tertiary amines do not show any reaction with this CHCl3 and KOH, that is chloroform. So we'll see first the general reaction and the examples and explanation based on this carbylamine reaction. Okay, so this carbylamine reaction, this reaction is also known as, this is carbylamine reaction. Okay, so this reaction is also known as Hoffman's carbylamine test. Or it is also called as isocyanide test. Isocyanide test. So the general reaction is amine, which may be your aliphatic or aromatic amine, particularly a primary amine. Okay, so this primary amine on reaction with chloroform, that is CHCl3, and KOH. 3 molecules of KOH we are using because for the stabilization of reaction products. So the product is nothing but the which on heating produces isocyanide RNC plus 3KCl plus 3H2O molecules. So this is nothing but the isocyanide. If you want, you please write down this reaction. We'll see the example. So the reaction can also be shown by the aromatic compounds. Suppose this aromatic moiety I have taken here, that is aniline. It is aniline and it is primary aromatic amine because NH2 group is there and this benzene ring is attached. That's why it is primary aromatic amine. This on reaction with CHCl3 and KOH on heating, what will be the product? That is benzene isocyanide. So this is the benzene ring which is attached to this isocyanide group NC. Okay, so how this isocyanide is written? That is N triple bond C, N plus C minus. Overall we are not giving any charge on this isocyanide group because one positive and one negative charge neutralizes each other. Similarly, as you may have gone through the nitro group, this nitro group is like this N plus and O minus, but simply we write this nitro as it is NO2. We are not giving any charge. Similarly, on this isocyanide group we are not giving any charge. Okay, plus you will get this byproduct, that is 3KCl plus 3 water molecules. Now with ethylamine, suppose this is the next example, CH3 CH2 NH2. With ethylamine I am writing this reaction in different fashion now. So this CHCl3, okay, 3 KOH, and on heating what is the product? So in place of just this NH2 group you have to add cyanide group, isocyanide group NC. That is the product. This is ethyl isocyanide. So this reaction is also called as step up reaction because if you see the functional group, that is isocyanide, one carbon atom is increased. Okay, first of all we will see this CH3 CH2 NC. Okay, how many carbon atoms are there? There are 2 carbon atoms. But in the product if you see, there are 3 carbon atoms including this isocyanide carbon. So this reaction is also called as step up reaction because one carbon atom is added in the product, final product, plus 3KCl plus 3H2O. Understand all of you this reaction? So we will proceed for the next reaction. So this we have seen, that is examples and explanation of this carbylamine reaction. Secondary amines cannot give this reaction because of absence of 2 hydrogen atoms. We require 2 hydrogen atoms for the conversion of this water molecule. Okay, so for reaction of this chloroform with this amine group, we require two hydrogen atoms which are not present in secondary and tertiary amines. That's why secondary and tertiary amines, if I write this statement here, okay, so the secondary amine, secondary and tertiary amines does not give this reaction. Okay, only primary amines can show this. Carbylamine test. Okay, so the next reaction we will see now, that is with aryl sulfonyl chloride. With aryl sulfonyl chloride. This is also simple reaction, just you have to remember the way of reaction, how this reaction is going to take place. So this reaction is used to distinguish the amines. Primary, secondary and tertiary amines are distinguished with the help of this aryl sulfonyl chloride. When this amine is treated with this benzene sulfonyl chloride, that is aryl. Aryl means here benzene group. Okay, so this is benzene sulfonyl chloride and excess of potassium hydroxide. The product is formed. We will see how different products are going to form with the primary, secondary and tertiary amines. Okay, so we'll see the explanation and examples of this reaction. So this is also called as this, first of all I write this aryl sulfonyl chloride. Okay, reaction with aryl sulfonyl chloride, or this reaction is also called as Hinsberg's test. Hinsberg's test. Now we'll see the reactant which we are using in this reaction, that is aryl sulfonyl chloride. So what is this structure? We are considering this benzene sulfonyl chloride. Okay, benzene sulfonyl chloride. How this structure is written? So this is benzene ring. To this benzene ring, sulfonyl group. This is CS double bond O and Cl. This is benzene sulfonyl chloride. This benzene sulfonyl chloride reacts with the amines. Now, how primary, secondary and tertiary amines are reacted, that we will see now. Okay, so just sliding this upside. If you have written with this structure, then we'll move for the primary, secondary and tertiary amines and the reactions of their classification. Okay, so here this primary amine, this is primary amine. So this primary amine, suppose I am taking directly example of methylamine CH3NH2. This on reaction with benzene sulfonyl chloride. So this is SCl double bond O in presence of potassium hydroxide. Okay, means base, KOH. What is the product now? So what happens here? This chlorine, okay, and one of the hydrogen atom, they are replaced to form HCl. Means here minus HCl, and the product is this benzene ring with S double bond O, and here NHCH3. This NHCH3. What happens here? This HCl is as a byproduct chlorine from this benzene sulfonyl chloride, and the primary amine contains this one of the hydrogen atom is replaced, and they give here this intermediate, and that intermediate is called as this N-methyl. Okay, this is N-methyl benzene sulfonyl amide. Okay, now again if I react this with KOH, now second time I am using KOH, means again a basic condition. Now what happens here? This OH group, again see here, this OH group abstracts this proton. So if this NH2 group contains two hydrogen atoms, one is abstracted by this chlorine to form HCl, second is going to abstracted by the KOH to form water molecule H2O, and this OK, okay, K, salt, that salt is going to form here. We'll see how this intermediate is formed in the next step. So this benzene, are you getting it? This is quite lengthy reaction, but it is a simple conversion of this abstraction of protons from this KOH molecule. N, okay, and here it is R, means CH3 group, here it is minus, and K plus. This is the salt. And at the last step, when you protonate this with the help of acid H plus, again you will get this N-methyl benzyl sulfonyl amide. Okay, now what is the product, final product of this reaction? So with this reaction, what we have achieved, that we will see now. This is S double bond O NHCH3, means a primary amine, okay, gives a clear solution of this salt. So this salt forms clear solution. So this is your soluble, this is soluble in because this is salt, okay, it is soluble, but which on again acidification produces the N-methyl benzene sulfonyl amide. This reaction can be shown by primary amine, okay. Now what is the reaction with secondary amine? So distinguishing reactions that I am showing you here after completion of all these reaction, what is the point of differences that we will discuss. Now the secondary amine. Secondary amine. How secondary amine is written? That is, this is CH3 NH CH3. This on reaction with this benzene sulfonyl chloride, S double bond O Cl. Now see here, this first step, this Cl and one of the hydrogen atom, they are going to form a byproduct, that is HCl, as we have written here in the first step for the primary amines. So this is the byproduct minus HCl, and the reaction takes place in presence of KOH. The first step is same for both these reactions. Okay. So what is the product now? So this benzene sulfonyl group and NCH3 CH3. This is NN dimethyl benzene sulfonyl amide. Now you can write the name also, NN dimethyl benzene sulfonyl amide. This on reaction, again, if you see the primary amine, we have reacted this particular content with 2 times KOH. So one time we have given this HCl as a product, byproduct. Okay. Again, if you try to react this with KOH, now this is the point of difference. Whether you have hydrogen atom which will be abstracted by this KOH, as like suppose here in this NH there is a proton which can be abstracted by KOH, second molecule of KOH, but is there any hydrogen which will be abstracted by this KOH? No. That's why no reaction. What is your output or interference from this reaction? That primary amines on reaction with a strong base like KOH in presence of benzene sulfonyl chloride gives you the salt which is soluble in water. Okay, but secondary amine cannot give such a soluble salt because of absence of one proton. Understand? So it does not give any reaction because there is no such proton which will be abstracted by the KOH, and it is insoluble in water. Okay. Now we'll see the reaction for tertiary amines. So this give no any reaction. So tertiary amines, what happens with tertiary amines? Now see here, if tertiary amines are taken, CH3 and CH3 CH3, this on reaction with benzene sulfonyl chloride, this reaction is very important. Okay, so in presence of KOH, what happens directly? It is going to form an insoluble compound which dissolves in acid. How? See here. So this is the benzene S double bond O double bond O. Now what happened here? This N, all the R groups CH3 groups. Okay, nitrogen becomes positive and in close vicinity there is chlorine. This is the salt. Which on reaction with this KOH again gives you this product. Plus R means your CH3 group, N, this is 3 times, plus Cl minus. Okay, so in this first step this KOH is not required because ultimately this benzene sulfonyl chloride and this tertiary amine going to form this type of salt, okay, which is soluble in water. Now these are the reactions which show the classification of primary, secondary and tertiary amines. Now we'll see the next reaction, that is reactions of diazonium salt. Reactions of diazonium salts. So there are 7 reactions. I have shown here the number that indicates something, that you can prepare 7 different substituted benzene with the help of this diazonium salt. Okay, which are those reactions? That is nothing but the Sandmeyer reaction. We will see these reactions one by one. Okay, so the second one, that is Gattermann reaction, then reaction with potassium iodide, then Walsh-Schiemann reaction, that we will see what is this reaction, that the reaction is used to form the fluorine substituted fluorobenzene. Okay, then with dilute H2SO4 with fluoroboric acid, and at the last we'll see the reaction with hypophosphorus acid. So these reactions we are going to see. So one by one we will see the reactions. And okay, so Sandmeyer's reaction. So Sandmeyer's reaction, before that just we'll recap for the formation of benzene diazonium chloride. Okay, so this is benzene diazonium chloride that we are going to form with this aniline. So this is aniline on reaction with nitrous acid. In previous lecture we have already seen this reaction, means NaNO2 HCl. Okay, NaNO2 HCl at cold condition gives benzene diazonium chloride. So this is N2 plus Cl minus. This is benzene diazonium chloride. Okay, in this reaction we will get the byproduct, that is HCl. So with the reaction with this aniline, means from aniline you can prepare different types of functional groups. Okay, so this nitrous acid on reaction with this aniline, that is nitrous acid is prepared from this sodium nitrite and HCl gives you benzene diazonium chloride, and this NaCl is a byproduct. Okay, sodium chloride. Now we'll see one by one the reaction. That is, first reaction is nothing but the Sandmeyer reaction. What is this Sandmeyer reaction? So directly we are considering the benzene diazonium chloride. Okay, Sandmeyer reaction. So Sandmeyer reaction is nothing but the when benzene diazonium chloride is reacted with, so this N2Cl, N2 plus Cl minus, when this benzene diazonium chloride reacted with copper halide in presence of HX, it produces halobenzene. So what is the drawback of this reaction? That this only produces only for this reaction can be explained only for chlorobenzene and bromobenzene. Okay, you can additionally prepare cyanobenzene from this reaction. That reaction is called as Sandmeyer reaction. So you can write both these products which are shown over here, that this N2Cl, N2 plus Cl minus, which on reaction first with copper. Suppose here this chlorine we are preparing, that's why it is copper chloride in presence of HCl gives chlorobenzene. Chlorobenzene plus N2. Same compound which when reacted with copper bromide CuBr in presence of HBr gives bromobenzene and N2. Same compound when reacted with copper cyanide CuCN in presence of hydrogen cyanide, again you will get this cyanobenzene. Plus N2. This is nothing but the Sandmeyer's reaction. Got it? Preparation of chlorobenzene, bromobenzene and cyanobenzene. So this reaction is again takes place with the freshly prepared, you can say the benzene diazonium chloride salt, okay, which when reacted with cuprous chloride or cuprous bromide, that produces the particular chlorobenzene or bromobenzene. Similarly for the cyanobenzene. Okay, we'll see the next reaction. The second reaction is nothing but the Gattermann reaction. Okay, let us see what is this Gattermann reaction. Gatterman reaction. So in this Gatterman reaction, you can say that the reaction is only with the chloro or bromo compounds. Okay. Now see here, when this N2 plus Cl minus. Okay, this is your starting compound, which when reacted with first copper in presence of HCl gives chlorobenzene and plus N2 as a byproduct. Similarly, in presence of copper and HBr, it produces bromobenzene and nitrogen as a byproduct. What is the difference in that Sandmeyer reaction and Gatterman reaction? In Sandmeyer reaction, we had used cuprous chloride or cuprous bromide, but here we are only using this copper powder. Okay, so this copper in the form of powder and in presence of HBr suppose or HCl, we are using this reaction. So this is only the difference. And if you compare the Sandmeyer reaction and Gatterman reaction, this Sandmeyer reaction is having better yield as compared to this Gatterman reaction. Understand? So this is the difference. In Sandmeyer reaction, we had used this cuprous chloride or cuprous bromide, but here just we are using this copper powder in presence of HCl. Same reactants and same product are going to form, but the condition reagents that are different. Now we'll see the next reaction if this is done with potassium iodide. Okay, the reaction with potassium iodide with Ki. So this reaction is nothing but the, if you try to perform this reaction as a Sandmeyer reaction or as a Gatterman reaction, the reactivity of this iodine is not as much that bromine or chlorine. That's why the cuprous iodized, suppose you are using for preparation of iodobenzene, does not give you the iodobenzene. Okay, so that's why this iodobenzene, whichever we are preparing, is just preparing with the help of this potassium iodide and on heating. Okay, it gives you iodobenzene. Therefore, when the solution of diazonium salt is heated with potassium iodide, then iodobenzene is obtained. So this is iodobenzene. For this reaction, this cuprous iodide, okay, it does not used. We are using potassium iodide. Okay, done with this reaction? I think this is a simple one line reaction. Benzene diazonium chloride on reaction with potassium iodide or on heating with potassium iodide gives iodobenzene. And here the byproducts are the potassium iodide, or your this chlorine is attached here, and plus nitrogen. They are the byproducts. We'll see the next reaction. Balz-Schiemann reaction. Balz-Schiemann reaction. This reaction can also be known as the reaction with fluoroboric acid. Okay, or you can say that the reaction with the which prepare the for preparing fluorobenzene. Okay, for preparation of fluorobenzene from benzene diazonium chloride, we are using this reaction. So this is benzene diazonium chloride, which on reaction with HbF4, this is also called as fluoroboric acid, okay, produces this salt, that the salt is nothing but this benzene, okay. Then here this N2, N2 is again plus, just this hydrogen is chlorine is replaced by this BF4. This is fluoroborate now, okay, which on further heating, on rearrangement, produces this fluorobenzene plus HbF4, okay, plus BF3 and nitrogen. This reaction is also called as Balz-Schiemann reaction for preparation of fluorobenzene. Now we'll see the next reaction. The reaction with dilute H2SO4. So what is the reaction with dilute H2SO4, that we will see. With dilute H2SO4. So this benzene diazonium chloride on reaction with benzene dilute H2SO4, N2 plus Cl minus, reaction with dilute H2SO4 gives phenol. Gives phenol. Okay, and the byproducts are nothing but the here this HCl plus N2. These are the byproducts. Okay, ultimately if you see this reaction, this NH2 group is converted to ultimately what is how this benzene diazonium chloride is formed with the help of this aniline. So aniline to phenol you are preparing. Okay. So the conversion of aniline to phenol to phenol. Okay. So this is the ultimate reaction. Understand? So this is negatively charged or electron donating group is there. This is also electron donating group. So this is quite like a nucleophilic substitution. But these aromatic compounds does not show nucleophilic substitution. Okay, so we'll see the next reaction. That reaction with again fluoroboric acid, which will be forming the nitro compounds. Okay, nitro compounds. This reaction is also with fluoroboric acid, but this reaction is going to form the nitro compounds. How? The second step is different with fluoroboric acid. With fluoroboric acid. So sodium nitrite we are using here. So what is the reaction? This benzene diazonium chloride N2Cl minus and this plus, which on reaction with HbF4, that is this fluoroboric acid, gives you the intermediate. This is the intermediate, that this N2 plus and HCl is a byproduct, that's why it is BF4 fluoroborate. This gives, in presence of sodium nitrite and copper, on heating, this nitrobenzene NO2 group. Okay, plus the compounds, that is nitro group, HBF, NaBF4. If you only heat this particular content, we have seen in the last for preparation of fluorobenzene, only we have heated. Okay, just heated this intermediate and we'll get the fluorobenzene. Okay, so the reaction is the second step is different. So this is the reaction with fluoroboric acid followed by sodium nitrite. Followed by sodium nitrite. Okay. Okay, we'll see the next and the last reaction of this lecture. That is the reaction with hypophosphorus acid. What is this hypophosphorus acid? So the reaction with hypophosphorus acid. Hypophosphorus acid, it is also called as phosphinic acid. Okay. It is also called as phosphinic acid and the formula is H3PO2. This is the formula, H3PO2. So there are more number of hydrogen atoms, means it is an acid. Okay. So just the salt is going to protonate. Which salt? That this benzene diazonium chloride salt is going to protonate this N2 plus Cl minus. It is going to protonate in presence of this H3PO2. Can you guess the product? It is nothing but the protonation, just the protonation. That's why it is hydrogen. This is nothing but the benzene. So we can prepare benzene also with the help of this hypophosphorus acid, or you can say this benzene diazonium chloride salt. Okay, ultimately what is the reaction? We have removed, ultimately we have removed this NH2 group, okay, from the benzene ring, and we'll only prepare this benzene with the help of this diazonium salt. So these are the different reactions which can be shown by this benzene diazonium chloride. Okay, so almost we have seen the 7 different reactions by using this benzene diazonium chloride. Understand all of you? Or the different reaction, there is another reaction for this. You can use different reagent also for this. So this is the benzene diazonium chloride N2Cl, N2 minus Cl plus. This benzene diazonium chloride on reaction with ethanol C2H5OH, that also produces this benzene. Okay. Just the proton donor is required. That's why this is the benzene. Okay. And the byproducts of these reactions are nothing but the N2 plus CH3CHO. Oxidation of this ethanol takes place, and HCl. Do you understand this? Also, if you try to write down the byproducts, I think I have not given here this. Byproducts are the nitrogen. Okay. Then here it is H3PO3. This is it, hypophosphoric acid. Okay. And then here it is HCl. Okay, I think this is more clear to you. So with this, so the 7 reactions we have seen under this heading, that is reactions of diazonium salt. In tomorrow's lecture we will see, or in the next lecture we will see perhaps, the reactions or electrophilic substitution of aromatic amines, that is aniline. On aniline, how the electrophilic substitution is going to take place, that we will see in the next section. So to summarize, we have seen the carbylamine reaction. In carbylamine reaction, so only primary amines gives you the carbylamine test. Secondary and tertiary amines does not form this carbylamine. Carbylamine is nothing but the isocyanide group. Okay, so this is NC, isocyanide group. Just recap we are having in 2 minutes. Then we have seen this reaction with aryl sulfonyl chloride. So primary, secondary and tertiary amines shows different reaction with this aryl sulfonyl chloride. Primary, secondary and tertiary. Secondary does not get solubilized. Primary gets solubilized, and tertiary directly forms salt before the reaction of acid. Okay, so this is the point of differences that I am just uttering here. Then we have seen reactions of diazonium salt. Almost we have seen the 7 reactions. In 7 reactions, we have seen about 10 different substituted benzenes. So we have substituted this N2Cl, N2 plus Cl minus group with chlorine, bromine, iodine, fluorine. Okay, then nitro group. Then we have substituted by the cyano group, then substituted by hydrogen, then substituted by OH group. Okay, so this 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. Okay, so with this, we conclude this session. So thank you. If you have any doubt, please post in comment section. And the description, you must see the description for the notes in next 5 to 10 minutes. I am uploading that description here. So thank you.